Algebra 2, Chapter 8 and Chapter 9 test. This test we had late last week. And this test review is going to go over all these problems. 1. Solve the polynomial equation by factoring. And here we have a quadratic trinomial. Well, it's actually a cubic trinomial. And because we have 2x cubed minus 5x squared minus 3x equals 0. So the first thing we do in looking at a factoring situations is see if we have a common factor in place. And we have x is a common factor. So x times 1 is 2x cubed, which would be 2x squared. And we have minus 5x minus 3 is equal to 0. So already we know that x is equal to 0. That's one of our answers. And so now we just have remaining 2x squared minus 5x minus 3 equals 0 to account for. And I suggest in this class using the x method or bottoms up method where we have a equals 2, b equals -5, and c equals -3. Well, AC will go up on top here, and AC 2 times -3 is 6. And then B down below, B is -5. What two numbers add up together equal -5, but multiply together equal -6. Well, they are going to be -6 and 1. And next we divide by A, and A being 2. So we simplify what we can. We have -3 on the left here. So we're going to have x minus 3. That's where this -3 comes from. And x plus 1/2. Now you notice I don't have an equal sign here because we're going to have to do a little manipulation. And the manipulation is this bottoms up. This 2 here, and the denominator will come and bottoms up over here. So equaling here becomes 20x minus 3. And then we have corresponding 2x plus 1. And we said each of these factors equals 0. So we have x minus 3 is equal to 0. We have x is equal to 3, which is one of our solutions. And then we have 2x plus 1 is equal to 0. Subtract 1. 2x equals -1. And look to the right here, we have divided by 2, we have x is equal to -1/2. So we divide by 2. So there we have it. And in the calculator, should you graph, and I encourage everyone to graph, please check your work. Go in here and you put in 2x cubed minus 5x squared plus 3x. And we graph this, and we can see a little bit here, -1/3, 0, 3. Then you can look at the table view. I'm going to go ahead and change. Now I have a second format. Just get a grid line for future problems here. There we go. Okay, yeah, we'll be able to see that. Anyway, you can adjust the table to see these zeros too, but I'm not going to go into that right now. Okay. Next, problem 2, which I changed from what the book gave. You look for a common factor here. And the common factor should be 3x So 3x times what equals 9. X cubed was going to be 3x squared. And we have minus 7x. And we have minus 6. And that looks like it right there. Okay, let's try this out here. We'll use, again, we're saying this equal to 0. So if we set 3x equal to 0, we have x is equal to 0. So that again, that's in part of 1. Next, if we set this, we have left 3x squared minus 7x minus 6 equals 0. And we go ahead and use our bottoms up arrangement here. 3 times negative 6. That's going to be negative 18. B is negative 7. What two numbers are we working with here? That multiply together equal negative 18, but when added together equal negative 7. How about negative 9 and 2? Okay, see that works out. Add those together, you get negative 7, multiply together equal negative 18. Divide by A, which is 3. So we get negative 3 and 2/3. So we have x minus 3. And then we have 20x plus 2/3. And we do our bottoms up arrangement here. We have 3x plus 2 is equal to 0. So we said x minus 3 equals 0. If x is equal to 3, which is going to be, and we have 3x plus 2 is equal to 0. Subtract 2. 3x equals negative 2. Subtract 3. X is equal to negative 2/3. So there that is. You can check all your answers using the graphic calculator. Next. A quadratic polynomial has at most how many x-intercepts? The answer to this one is 4, which is C. When you do in your calculator, this. You have on your K4 calculator, if you go to Stat Calc, and you sort of look, see what's happened here. You got linear 4 here, linear, that's 1. X power 1, quadratic x power 2, cubic x power 3, quartic x power 4. And I don't think they have a quintic in this one, but the x power 5. So just a memory aid on the calculator should be that simple. Okay. Which the following lists all the roots of x to the 5th power minus 3x 4th power plus 3x 3rd power minus x squared minus equals 0. And so in this case, you have a common factor of x squared in each term. So you have x squared times x to the 3rd power minus 3x squared plus 3x minus 1 is equal to 0. And so now you know that 0 is a root. So any answer choice that does not have 0 as a root is a wrong answer. B is a wrong answer. And so you can either take your factored portion here and put that in the calculator exam, or you can put the whole thing in and take a tight look at it. I'm going to put the whole thing in there because I anticipate that's what a lot of most of you did. And that's really kind of a good strategy. Think about it. So yeah, x to the 5th power minus 3x to the 4th power plus 3x cubed minus x squared, and that's all equals 0. So we see where the function touches across the x-axis. That would those would be our answers. So we graph this, what looks like. We see a really tight situation here. We see that -1 is not anywhere in the picture. Okay, so that enables us to go back to our answer choices. Any of these things with -1. Okay, so by process of elimination, we've already chosen C as our correct answer. Again, just a tighter view, looking at what's happening here. You can go to window. I'll go like from -1 to 2, go to I leave that scale the same, y minimum -0.5 to 0.5. You just be able to see more. So the thing is touching at 0 and at again at 1. And again, you can tighten up the window a little more to see it better. Go -0.1 to 0.1. I think that the test ride was triangle. Yeah, you can see it like that here. So again, test rider is trying to test your analysis skills. Okay, which these 3-degree polynomial has only one real root. And I'm not going to go over all these except to I'm going to enter the correct answer choice, which is C. So we go to here. We have 8x cubed minus 12x squared plus 6x minus 1. Graph. I'm going to zoom 6, get the window back again. And then you can do a tight view of this. You can see that it touches the x-axis just one place. The others answer choices A and B will touch in 2 places. C is our correct answer. Next, 6. Solve the polynomial equation by finding all real roots. And basically what you're looking at is this. If you just enter this in the calculator, I saw people start to use the rational roots theorem and get potential rational zeros, which is a start to answer the question, but does not answer the question. So an answer is going to be x equals some numbers, okay? If you have more than one, it's going to be that, or it's going to be in set notation. X equals some kind of the bracket where you have numbers here, okay, like 1, 2, 3, or whatever. Okay, that's what the answer should look like. Shouldn't look like just the numbers written down and circled, right? It should be x equals something. That would be a proper looking answer. Okay, next. Let's go ahead and just graph this and get a start on it. So we go back here, x to the fourth power minus 12x squared plus 27. Oops, we messed that up, didn't I? X to the fourth power plus 12x squared plus 27. Now we should be all right. June 6. So we can see pretty clearly that we have zeros here at x equals -3 and x equals 3. And so you can check in your table view. Yes, at -3 and at 3. And then we also have the zeros in between -2 and -1, and between 1 and 2. It looks like we have symmetry about the y-axis. So you kind of look this in a number of ways. Some people did a graphical type of solution to it. So put our zeros here, we can just factor out and see what we have left and then solve from there. So we have 1x to the fourth power, 0x cubed, -12x squared, 0x, and then 27. That's 27. Bring this down, we have 1. 1, 3, 3. 3 times 3 is 9. -12 plus 9 is -3. 3 times -3 is -9. -9 down here. 3 times -9, -27. So here we have x cubed plus 3x squared minus 3x minus 9. We can just come down here again and put in our other zero that we found here, which is -3. So I'm going to say, right now, I'm just going to say x equals -3, x equals 3. So we know those are zeros already. Now we'll find the remaining zeros. And down here, 1, and 3 times 1 is -3, 0, and 3 times 0 is 0. We have -3, and 3 times 3 is 9. So we have 0 here, so we have x squared minus 3 equals 0. And we solve for this, we add 3. We have x squared is equal to 3. We have x is equal to, take the square root of both sides, plus or minus square root of 3. So these would be our other two zeros. Okay, now one thing to do in the calculator, and some of you did this, was actually get a decimalized approximation. If you have a second trace, get a 0. You can go to left bound, and you can come over to the left. And you go to the left here, press enter. It says right bound, press enter again. -1.73. So x is equal to -1.73. And also you do the other one, you have x is equal to +1.73. Well, as it turns out, these numbers are approximately equal to the plus or minus square root of 3. So if you ended up getting a decimalized answer that was relatively close, you still got credit, although you did this by a different means. Because here it doesn't say, it doesn't give you limitations, does it, on how to find your techniques in finding real roots, but just find them. And if you did that and got approximately close, then that's a valid technique as well. Okay. Okay, here we go. Let's go on to number 7. We have this polynomial equation. Let's just go ahead and start by graphing as we did on problem 6. So we go to clear x to the 3rd power plus 6x squared plus 9x plus 2. And we can see where the graph touches or crosses the x-axis. And I think we can see pretty clearly here at x equals -2. So yes, at x equals -2, we have a 0. So we have x equals -2 is going to be one of our solutions. And we have 2 other solutions that we're going to try to spot out. So we take our 0 of -2. We put inside here 1, 6, 9, 2. So we get 1. -2 times 1 is -2. 4. 2 times 4 is -8. We get 1. 2 times 2, 0. So we get x squared plus 4x plus 1 is equal to 0. And we have a situation here where this is not factorable. And we can solve this in a number of ways, one of which is to use the completing the square. I'm going to do a couple different ways. A lot of you, what you did is this, and got an approximate solution in this manner. You went to the calculator, and I believe, just based on what I see, if you go second trace 0, and you want to find each of these zeros, you go to left bound, press enter, go right bound, press enter, and then we get -0.27. Okay, that's an approximate answer. Second trace 0, we come over, go to the left of the other x-intercept, press enter. On the right, press enter, enter. -3.73. So x equals -3.73. X equals -0.27. So these would be possibilities done this way, graphically, using the tools in the calculator. But other methods, you can complete the square. If you have, what do we have to add to this on the left side to get a perfect square? Well, if we take 4 divided by 2, we get 2, and 2 squared is equal to 4. So we have to get 4 on the left side, so if we add 3 to both sides of this equation, we get x squared plus 4x plus 4 is equal to 3. And then we can rewrite this x squared plus 4x plus 4, the perfect square is going to be x plus 2 squared equals 3. And we go ahead and take the square root of both sides. So we get x plus 2 equals plus or minus square root of 3. And then we subtract 2. We have x is equal to -2 plus or minus square root of 3. And this would be an exact answer. It's the same equivalent answer as this one up here, right, as these two. So on your test, I was looking for different ways of you expressing that. Again, you can use the quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. In this case, you have a is equal to 1, b is equal to 4, and c is equal to 1. So you have x is equal to negative 4 plus or minus square root of 4 squared is 4 times 1 is 1 over 2a, which is 2 times 2. So you end up with x is equal to negative 4 divided by 2 is going to be negative 2. And then you have this 4 squared minus 4 times 1 is going to be plus or minus square root of 12 over 2. And square root of 12 over 2, square root of 12 can be rewritten as square root of 4 times square root of 3. And so you have 2 square root of 3 over 2. So you have 2 plus or minus 2 square root of 3 over 2. So you have again 2 plus or minus square root of 3. So different ways of solving this problem. Next, problem 8. Let's go ahead and look at the same type of situations we did before. Graph this. 6x cubed plus 7x squared minus 9x plus 2. That looks like you have a 0 at negative 2. So you take that. So try this. And x equals negative 2. I didn't check it just then with the calculator, but it really is. You take negative 2 out here. 6, 7, negative 9, 2, and down to 6. Negative 2 times 6 is negative 12. Negative 5. Negative 2 times negative 5 is 10. Negative 1. 2 times 1 is 2, 0. So we get 6x squared minus 5x plus 1 is equal to 0. And then we bottom up this thing we did before. We get AC is 6. B is negative 5. Our two numbers here we need are negative 2 and negative 3. Because we multiply together, they equal 6. Add negative 5. Divide by 6. So we get negative 1/3. And then negative 1/2. So we get x minus 1/3. And then x minus 1/3. And we bottoms up both of these. We get 3x minus 1 and 2x minus 1. We set these equal to 0. So we have 3x minus 1 equals 0 using the field factor property, and 2x minus 1 equals 0. And solving both of these, we adding 1 to both of these equations. We get 3x equals 1 and 2x equals 1. We have x equals 1/3, x equals 1/2. And let's go look at that calculator again to be sure that makes some kind of sense. Yeah, and then you can take a tighter look at it with your viewing window. But these would be all of our answers. And then you can write this as x equals in set notation. And we have 1/3, 1/2. And usually you want to do that in the order of going from least to greater. So you put x equals -2, 1/3, 1/2. So this would be just another way of giving an answer. But it shouldn't be just the numbers themselves unlabeled. It has to be x equals something, somehow. Okay. Next, 9. Find all the observed functions whose multiplicity is greater than 1. So again, we can take this out. Understanding what multiplicities are is what asked me during the test. One thing that's going to be helpful for you is in my pre-calculus class next year is if you have this, we talk about multiplicity next year in pre-calculus, you'll have a lot better understanding of what those mean. And some of your answers really did indicate very precisely your good understanding of that, which is a good thing. So here we have x equals -1 and x equals 2. We can verify that with the calculator. X equals -1, x equals 2. You see we have that. And so we have x equals -2, x equals 1. We're at, oops, at -1, we have a multiplicity of 1 that we cross the x-axis. And then this one at x equals 1, just touch the x-axis. The multiplicity is equal to 2. So that should be our I got these messed up, don't I? Let me see. Let me get these right. Yeah, x equals 2 multiplicity of 2. X equals 2 multiplicity of 2. So I'm doing what someone here in the test was. Yeah, look, I corrected, right? X 2 multiplicity of 2. X equals -1 multiplicity equals 1. There we go. So that's 9. 10. Yeah, 10 should be one of the easy ones. X cubed minus 5x squared plus x minus 5. So x equals 5 is our 0. You can see x equals 5, 0. X is equal to 5. And we cross the x-axis, so our multiplicity is equal to 1. This would be our answer number 10. Number 11, we have x squared, x cubed plus 6 x squared plus 9x, 9x plus 2. So we graph this here. We have a 0 here at negative 2. So we come out here at negative 2. Let's see what that looks like at negative 2. It looks like a multiplicity of 1. Okay, negative 2, we have 1, 6, 9, 2. Bring this down 1, 2, 4, negative 8, 1, 0. So we have x squared plus 4x plus 1, and that's equal to 0. So we have similar to what we had this other time. So we have negative 2, and again, if we leave the square like we had 1 plus 4, of course we have x squared 4x plus 4 equals 3. So we have x plus 2 squared equals 3. Take the square root of both sides. We have x plus 2 equals plus or minus square root of 3. So we have x is equal to negative 2 plus or minus square root of 3. And that's going to be multiplicity of each is equal to 1. Which is very similar to the one we did earlier on number 7, it turns out. Okay, so that's the brutal first page of the way the test was outlined. Let's go on to the second page. Are each following roots of the function f(x) is 3x cubed plus 15x squared plus 4x plus 16? And we can go to the calculator, put that in. We got 3x squared, 3x cubed, plus 17x squared, minus 54x, plus 16. So we graph. So we don't have a 0. So we have negative 8 and 1/3 and 2. And negative 8 and 2 should be pretty easy to see. One thing you can do on your table set to take the thirds, if you table start someplace at 0, let's say we table start at 0, and we go up to 1 delta table 1/3, we would be able to go ahead and see in our table view at x equals 1/3 we have a 0. So by changing our at 2 we have a 0, and at negative 8 we also have, that's 9 times 10 to the negative 11th. That's like trillions. Okay, that is 0. It's just sort of rounding. You can see it today for series calculators. So yes, so our answer for this one is going to be yes. 0 is a no. 1/3 is a yes. And 2 is a yes. Because we have a cubic function here, we only have a maximum possibility of 3 of these being correct. Let's go on to 13. Each equation is K a constant variation. In the case of A, yes, direct variation. In the case of D, yes, inverse variation. These other situations, B and C, your K is in the place of a base or an exponent. So for B and C, no in both cases. And if you got something wrong here, I proportionally took off. Okay, write an equation, related variables, and equation solve the problem. If x varies inversely with y, so x varies inversely as y. That's what the thing looks like. Or you can write this as y. Okay, so either of these would be the same thing. Okay, so x equals 5 when y equals 3. So if we use this going to right, if x equals 5 when y equals 3, so we have that, we multiply, a is equal to 5 times 3, or 15. And so we have, now we can plug back in y is equal to 15 over x. And then when x equals 18, well, we have y is equal to 15 over 18, which simplifies to 5/6. And some of you gave me the decimal version of that, which is 0.833, I think, which I said is okay. 5/6 is the correct answer. Next, 15. Same type of situation. We have y equals a over x, and we're going to replace these now when y equals 1/4 a over 24, and we cross multiply. A is equal to 24 times 1/4 equals 6. So we have y equals 6 over x. Now we plug in here, we say, okay, y equals 6 over 2. So y is equal to 3. Okay, 16, volume of gas, constant temperature varies inversely as the pressure. Okay, so volume varies inversely as the pressure P. There we go. And a gas occupies volume of 2 liters at a pressure of 14 newtons. So A is equal to 2 times 14 equals 28. So that is our constant variation. So we have volume equals 28 over T. So now, just working the right here, volume is equal to 28 over 25. And so that's going to be it. What is that going to be? 2 liters, right? So this will be right there. And then some people gave a decimal approximation, 1 point something. Okay, the maximum load of horizontal beam varies inversely with distance. So the L varies inversely as a distance D. Okay, a beam with 16 feet between them, supports has, well, I got that wrong. Okay, with 16 feet, between 16 to go down here, right? And 350 goes over here. So A is going to be equal to 16 times 350, and that is going to be 5,600. So we have L equals 5,600 over D. And then we say if we have 20 feet here, L is equal to 5,600 divided by our distance, which is 20. So we have L, which our load, equals 280 pounds. LBS, pounds, Libra. Okay, 18 is each set of data show inverse variation. So what you're looking for is inverse variation. You're increasing in opposite directions. Here in A, you're increasing the same direction, so we are not having inverse variation. Now for B, we're going down, up here, down here. So yes, inverse variation. B, and then we have C, both are going up. That is direct variation, possibly. And then in D, we have inverse variation. See, if you multiply all these together, 0.3 times 10 is going to be 3. 0.4 times 7.5, that's 3. 0.6 times 5, that's 3. But they're going opposite directions. So there you have. So this is what it should look like for 18. Okay, so that's page 2. Now we're to the last page. So true or false for each statement about the graph, the rational function. And we have the rational function fx equals 3x plus 4 over 2x minus 7. Horizontal asymptote. Well, horizontal asymptote we can find by taking the highest powered term in the numerator and denominator. So our horizontal asymptote is going to be the equation y equals 3x over 2x, which equals 3 halves, which equals 1.5. So horizontal asymptote y equals 1.5. So this is false here, and C is true. Next, for vertical asymptote, we have to have our denominator equal to 0 to have vertical asymptote. So we have 2x minus 7 is equal to 0. 2x equals 7 divided by 2. X equals 7 over 2, which equals what does that equal? 3.5, right? So x equals 3.5. That's our vertical asymptote. And then that shows up D is true, which means C is D is false. Okay, 20, membership in fitness club. And I gave them I think the exact problem in the test preview. So write a rational function. So average cost is going to be equal to our one-time registration fee plus 45 per month. But what we're doing is our average monthly cost is going to be found by taking this average one-time registration fee and dividing it by X. So that's what this is going to look like. That's our average cost. And then if we want to find for 6 months, okay, average cost. Okay, for that we have 102 divided by 6 plus 45. And that's going to equal $62. Okay, so these would be our answers. And I think it was exactly the same in the preview. Now 21. Identify the horizontal and vertical asymptotes of the function. Then graph the function. And you really have different options for this. Analytically, there's a way to go. We did that in the class. There's also just using the calculator. Now, we should already know that you're well, remember that the fx equals a times 1 over x minus h plus k. Well, this -3, k is equal to -3. And so what we have is right here, y is equal to -3. So that would be our horizontal asymptote. Now I was quite picky about this because I saw a lot of like y equals -3. Well, that's, or just -3. Okay, and that's not a complete answer. You have to have really a fully articulated answer. That's our horizontal asymptote. Our vertical asymptote we can get by setting our denominator to 0. So if we have 3x minus 6 is equal to 0, and 6. So we have 3x is equal to 6 divided by 3. We have our vertical asymptote, x is equal to 2. So here we have x is equal to 2. That's our vertical asymptote. Again, but what I saw in the class is just, in instances, just inadequate articulation of what that is. So now it should be -2. We set this equal to 0. Oh yeah, this is how I did it. I got it wrong here because I put +6 there. So I just started out wrong. I'm going to fix everything. I'm going to fair. Okay, so now we subtract 6. So we have 3x equals -6 divided by 3. We have x equals -2. So let's go ahead and change all this. See, it's okay to make mistakes, but you should, like I did just then, be able to check yourself. X equals -2. And then we're going to graph too as well. And then as far as what we're going to have is a is going to be equal to 1/3. And so that, and how I know that is because we have 1/3, because we have like 1/3 times 1 over x plus 2. See that? So a is 1/3. So we come like this, 1/3, 1/3. So things will look like this. 1/3, 1/3. And I'm not looking for perfection in the graphing. So it's going to look something like this. But again, I'm looking for correct articulation in This vertical asymptote, x equals -2. Horizontal asymptote, y equals -3. And now the calculator, we go here, clear, 1 over 3x plus 6. And we put outside here -3. We see that we have our horizontal asymptote and vertical asymptote correct situations. So that looks good. Okay, last problem, 22. Write the function graph below in the form fx equals a over x minus h plus k. And here we have h is going to be equal to 2. K is going to be equal to, looks like, it's 4, 2, 3, looks like 3. So we know we're going to have f of x equals a over x minus h, which is 2 plus 3. And if you got this far pretty much and then get a right, I gave you, I think, half credit on that already. But now we can plug in the values given. So we have this point here, 6, 4. And so we say 4 is equal to a over 6 minus 2 plus 3. We're just plugging in 4 for f of x and 6 for x. So we have 4 equals 1/4 a plus 3. We subtract 3, we have 1 equals 1/4 a, and we multiply by 4, we have a is equal to 4. So our equation is going to be f of x equals 4 over x minus 2 plus 3. And I had quite a few people get this one right. Anyway, that's the test. Hope it's been helpful to you. Well, I did quite well on this. Good job, and thanks for viewing.